As all the team members are keen in natural sciences, it was strongly suggested by everyone to get inspired from science throughout the project. Therefore, we created the name of our team to reflect the metaphor between the high speeds achieved by Formula 1 race cars and the speed of sound. Similarly, the logo of our team is an allegory between the ultrasound motion and the Formula 1 race car. Moreover, the goal of our team is to compete in the National Formula 1 in Schools contest, but also to enhance our knowledge. Regarding the tasks of the project, these were evenly distributed between the team members in order to achieve the best operation of the team. More specifically, Angelidis Nicholas was a mechanical engineer and he was responsible for the guard design and the construction of the wind tunnel. Ioannou Panagiotis was a construction manager and he helped building the pit and also was responsible for the risk management. Mamoulova Eugene was a graphic designer and she designed the team's logo and pit. Hadjimiltis Christodoulos was the marketing manager and he approached the sponsors. Paraskevopoulos Mikhail was also a mechanical engineer and he was involved in the designing process of the car and the team portfolio. Theophanis Rogiros was an engineer with contributions into the innovation of the team with application in the race car and the pit.
We're 6 students and friends that are studying on IMS and really like maths and physics and want to study about engineering. We all then decide to become a group and participate in Formula 1 competition because we all like it and we are interested to learn more about it, which was a challenge for us. As soon as we became a team, our graphic designer created a logo which represents speed and strength in science, but also catch the eye of the spectator. By considering our tight budget, we concluded that custom uniforms were at the top of our list, so we continued with more serious things. Since all the other components of our identity integrated our strong, competitive yet organized character, the same should apply for our model car. Therefore, the graphics used have our team's color.
As with every project, the main challenge that we had to cope with in our project was time management. Since each of our members had lots of extracurricular activities, we weren't able to organize regular weekly meetings. So, because we realized that each moment that we had together was invaluable, we organized our time in the most efficient way. By giving certain activities certain time limits and by giving the possibility for extensions where needed, we were able to correspond to every deadline that we had. Moving on to communication, I must say that the most important means of not only to communicate with each other but also to get in touch with the people that are interested in the F1 in Schools project was our Facebook page. Through the page we were able to share our progress, everyday progress, and also to advertise our sponsors. Several other programs that were used in the process of creating this project were Microsoft Link and Skype, with which we were able to communicate and share content with each other. Also, Google Drive enabled us to have our files, our project files in any computer that we had the chance to work on. And also through our team meetings, we were able to work together and create and share ideas one-on-one and also with the entire team.
As the main goal of the entire project was to put ourselves in the place of big manufacturing companies, we were greatly inspired by their approach to sponsors as well. Each sponsor was handled with a different plan according to each one's characteristics and aspects. Therefore, it was our duty to show our progress to our sponsors, and in return we pledged to advertise the sponsors through our team's successes. Our biggest sponsors was our Institute of Mathematics and Sciences, IMS, and Mrs. Shertis Ritsa's private institute, which have provided almost 65% of our budget, and we thank for that. We also want to thank our smaller sponsors for their contribution.
Graphic design. The designing of our logo was performed using several softwares, but mostly using Photoshop. Several drafts were drawn by hand, and by selecting the best part of each draft, we reached the final design and then we digitalized it. Now for the pin design. Several draft ideas had been proposed for the design of the pit used during the exhibition, but no certain decisions have been made yet due to the increased attention given to the design of the car. In addition, the material used will be decided after all the car manufacturing costs are over. However, an approximation of its cost had been considering the expenses pie chart. The main goal is to achieve a design that it is easy to carry and set up, as well as inexpensive. Few of the ideas include using canvas cloth, hinges, cardboard, wounded supports, and recycled materials. Relations to education. We attended a seminar in the Frederick University in Nicosia regarding the operation of the simulation of laws that accompanies the SolidWorks platform, and while using it we became familiar with the SolidWorks environment. Furthermore, after all this time that we have been working on the Formula 1 project, we extended our relevant existing knowledge to a new level. From our involvement with the F1 in Schools project, we enhanced our critical and creative thinking, and we came up with new inventive ideas and used them for the benefit of our project. We had the opportunity to deepen our knowledge on aerodynamics and also became familiar with programs like SolidWorks, Photoshop, Windows, Excel, and PowerPoint. And moreover, we gained valuable skills for managing time, funds, and research to successfully carry out a complex project. We had the opportunity to make research about aerodynamics and through them learn and understand their philosophy and applications in real life. We also learned how the philosophy changes according to the goals of an application, and of course, after understanding it, we found creative ways for applying it to our project.
Theoretical background. Aerodynamics is the science that studies an object moving through air or another fluid, and it was introduced in racing to create a downward force and increase the grip of a car while turning. Using aerodynamics, you can also achieve to minimize the air drag which slows down the car. Now, air drag is the resistance that an object experiences when moving through a fluid. There are two kinds of air drag, parasitic and induced drag. Parasitic drag is caused by the friction between the air molecules and the surface of the car, while induced drag is caused at the ends of the wings of the car due to pressure difference on top and bottom surfaces, causing a lift of the wing, which slows down the car. To reduce these drags and therefore decrease the force opposing the motion of the race car, the edges should be as smooth as possible to reduce turbulent flow across the car. According to our research, we found that could be achieved by using fillets on most edges and by using the droplet shape, which is the most aerodynamic shape. Testing. After the theoretical research and just before completing our model, it was thought that we should test it in real-life conditions, so we decided to construct a wind tunnel to test the aerodynamic behavior of the final designs, and because 3D printing wasn't the faster way, we created a model of our car with clay so as to test it. The wind tunnel was manufactured after studying the background theory of professional wind tunnels and was carefully designed. We mainly used recycled materials that were selected for their strength. Now, as for the airflow through the wind tunnel, a brushless DC motor was purchased that had 1 kilogram of output power so that it could create the airspeed we needed. Our clay car was sculpted in exact dimensions to model the Formula One car, so as to test it before concluding the design and setting the blueprints for manufacturing at the Frederick University. Now, aerodynamics were not the only thing we had to consider. We also came up with new technologies for reducing other forces opposing the movement of the car model, like friction at the axis of the wheels. Our idea was to use electromagnetic forces to make the axes repel the wheels, causing them to hover around them and spin freely without any friction with the axis. The idea was to charge the wheel and the axis with the same charge so that they would have repulsive electromagnetic forces equal to Q times Q over R squared. When we tried to practically test the forces that were supposed to keep the axis away from the wheels, they didn't. And after some research, we found out that the electric field strength inside geometrical shapes, like a circle, or in 3D a sphere, becomes zero, so the forces also become zero. Now, after our first failed attempt to reduce the friction in the wheels with electromagnetic repulsion, we decided to use bearings to reduce friction. Now, as it turned out, bearings create even more friction than the plane axis. So in the end, we decided to use the wheels provided instead of using a new technology.
Moving on to our car's design, we are able to see that it is really a multi-stage process. The first two pictures show the first attempts that we had to experiment with the basic design that was provided to us by the competition, as well as another design developed by our team members, which were quickly rejected and perfected to our final design, which cooperated the flow of air around the wheels and the body with smoothed edges using fillets, and also the experimentation with an underbody diffuser. A more detailed design included at the end of the document, where the diffuser is also shown.